So now we are going to see about ray optics and optical instrument. So in this scenario, you know very well how the rays will flow. How the rays will flow. This already what comes to your mind of rays? The moment you say rays. Beam of light. Beam of light, sunlight, beam of light. This beam of light is you can take. You can take this beam of light, and you can take sunlight also. And other than that, any other example is there? Beam of light, sunlight. No, UV rays that will fall into sunlight. Sunlight, sunlight, moonlight, sunlight, moonlight. This light you can take. So three example you can take, and we can something will fall on the so some beam of light is passing on to the material. So that material. So this in this scenario, two types of material it will comes. So one is that first one is it could fall on the human body. Okay. So next is it could fall on the glass. So it's glass. Then it's fall on the okay, you take a wall versus glass. If the rays fall on the wall, what will happen? If the ray fall on the glass, what will happen?
Refractor.
Glass?
Refract agum.
Where?
Glass la water oothi vecha.
No, nothing. We are not doing anything. We are just
reflect agum.
No, we are just watching sunlight falling on the glass and sunlight falling on any wall. What will the observation? Sunlight falling on the glass. You can go outside itself. Now itself you can go outside and watch sunlight falling on the glass, sunlight falling on the wall. So what will happen? What is the difference between those two?
Glass will reflect.
Glass will reflect. Wall will not reflect. So this here comes the new concept called reflection, refraction, dispersion. Okay. So in this scenario, now a new concept of reflection, refraction, and reflection, refraction, and dispersion. So new three concepts are put into effect. So in this scenario, first we can go, sir. So you can know that angle of incidence is when a light is reflected on the when the light is reflected on the any glass surface, something reflection will take place. So the angle of incidence is equal to angle of reflection. So this is the law of reflection. So the angle of incidence is equal to the angle of reflection. So this is the law of reflection. Now in the same scenario, if I take and its focal length is given by f. For example, any the distance between the focus f and the pole P of the mirror is called the focal length of the mirror. Okay, and it is denoted by f. So its f is given by r by 2, where r is the radius of the curvature. Correct, radius of the curvature of the mirror. So f is equal to r by 2. Then in the same scenario, we can go for mirror image. So what is the mirror image? Mirror image is a one. For example, if the things like if you take we are viewing some first we are taking some some mirror. Okay, anyway, it could be convex. What are the two types of mirror? Convex and concave. We are taking from here itself we can view from my position. I am viewing the wall. So instead of wall, I am replacing with the convex mirror. So the convex mirror is there, means what will happen? I am seeing this. I am seeing the convex mirror. So this is my I am seeing the convex mirror. So from my point of view, from my point to the convex mirror, then you can see that you can keep some object. You can keep some object at the between us. So you can place the light. You can place some object here. Okay. So yeah, you can take my example. I will be placed here. I am placed a convex mirror there. then in between I am placing one small mirror in everything, which is the image. So can I see my any image or any image, or you can keep some ball also here, some ball here. I am keeping some ball here in my point. That's a convex mirror. So then downstairs I am keeping some mirror. So can I see the mirror or not? Can I see the ball or not in that mirror?
Convex.
Not in the down mirror, in the down position.
Yes.
Yeah, how you can see that position? How you can see that ball? The ball is here. Convex mirror, concave mirror is there. Then in the down it is one more mirror is there. So I'm just seeing it. I'm going to see that mirror. Can I see that mirror or not?
Yes, sir.
How I can see that mirror?
That's reflection.
That's a reflection. Example of the reflection. So that's an example of the reflection, stating that the angle of incidence is the same thing, same point. Angle of incidence is equal to angle of reflection. Reflection. So it's given by, what is the equation? Mirror equation. 1 by V plus 1 by U is equal to F. F is the focal length. F is the focal length. V is the distance from the mirror, that mirror to this small mirror, and we use the total distance from this position, from where the ball is placed to the concave mirror. So in the same, now we go for second part. What is the second part?
Law of refraction.
Law of refraction. So refraction means, so if the refraction means what is the things is the opposite to the reflection. That is, the light incident which is get reflected means the refraction. That means what do you mean by then what is the main difference between the reflection and refraction? Main difference. It passing through not object, it passes through the medium. As any medium if you take, no, you can take you can take some points if it is it passes refraction, it passes through the medium. If the rays that could not pass through the medium is immediately it will be reflected back. So that is the law of reflection, this is the law of refraction.
What about refraction, sir?
Refraction, it will pass through the medium. It will pass in refraction, the rays will pass through the medium. Okay? In reflection, it will not pass through the medium, so it will be reflected back. And its value is given by refractive index. Refractive index is given by refractive index N21. Refractive index of 21 is given by sine of incidence divided by sine of refracted. Sine of refracted. Yeah, is given.
Yes.
Sin I by sin R. N is nothing but refractive index. Okay. Constant or refractive index. That is in the same scenario, you can see sunset and sunset and sunrise. This example I gave.
Yes.
Which example I gave? Sunset and sunrise. If you see after 6 o'clock, early 6 o'clock, you can see some white light in the. You can see some. You can see that before sun comes, sun will arise only 6 o'clock. But in 5 o'clock itself, you can see the light glooming of light. Some light you can see and around early morning 5 o'clock itself. So that is due to because of refraction. Then in the same scenario, evening after 6 o'clock, once the sun set, again till 7 o'clock. Not 7 o'clock, 6:30, 6 to 6:30, 5:30 to 6. Here you can see that shadow. You can see some lights. That is the example for refraction. Then total internal refraction I gave. Total what is the total refraction I gave? when light travels from optical denser medium to rarer medium, it is reflected back into the same medium, the partially refracted to the second medium. So this reflection is called internal reflection. So in this scenario, now if I see that what is it that for refraction, what it is, sin I by is equal to n equal to refractive index. Since sin I by sin r in the total internal reflection, sin I by sin r, no, not sin I is equal to n refractive index. Sin I is equal to sin I is equal to refractive index, because sin r becomes 0, 1, sin I become 1. Sin I by 1 is equal to refractive index. Sin I divided by 1 is equal to refractive index. Sin I divided by 1 is equal to refractive index. Then what is the next topic? Mirage. Mirror image. Mirage.
Total reflection in nature.
Total internal reflection is in the nature. Mirage. No, that topic is, you have to tell me what is the total mirror, total internal reflection in nature. So in that scenario only, mirage, diamonds, prism, optical fibers, then optical fibers. Okay, so 4 is there. So mirage, the mirage means you can see the refractive index of air increases with density. Hotter is the smaller has smaller refractive index than the cooler air. What is the definition I gave for mirage?
During summer, the ground become hotter than the air at the higher level.
Yeah. Okay. So then the refractive index of air increases with its density. Hotter air is less dense and smaller refractive index than the colder air. So if the current air is smaller, then air is optical density of the different air of the air increases with the light. Okay, no, that's sufficient. How many sentences I give?
Hotter air less dense and has smaller refractive index than
Cooler air. Okay. Then diamond. So diamond is are known for this. The total internal reflection of light inside them, critical angle for diamond and air phase is 24.4 degree. This I gave?
No, sir.
Okay. No, what I gave for diamond?
The critical angle for diamond is very small.
Very small. Okay, that's fine. Then?
Hence, when the lines enter the diamond, it is very likely to go total internal reflection inside.
Okay. Then prism. Prism is designed to bend the light by 90 or 180, making the total internal reflection. Okay. Such prism is also used to invert images without which are changing their size. That means what their size, the size is there, it will be inverted. You don't understand. You could understand, right?
Yes, sir.
So because my image is there, If you are seeing that image, that side, how my image will be there?
Inverted.
Inverted. Inverted means how my image will be there. How my image will be there?
Just opposite to the side.
No, yeah, opposite of it. How my image will be? My head will be down, leg will be upper. That's all. That's an inversion image. Optical fiber. So optical fiber to makes use of phenomenon of internal reflection fabricated with a high composite of glass and quartz fibers. The refractive index of the material of core is higher than the clouding. Okay, that's all. No.
ಇಲ್ಲ sir.
Uh,
It is extensive for transmitting audio and video
through long distance. Through long distance. Then
It involved the principle of total internal reflection.
reflection. Yeah, that's sufficient. Now then refraction by refraction at the
spherical surface.
spherical surface and by lens, right? Then
Refraction through a prism.
refraction through
Prism.
refraction by spherical surface by the lens
Through prism.
through prism. Okay, through prism. Okay, so in this scenario first we are going to refraction at the spherical surface. The spherical surface in the shell in the spherical surface, if you see that spherical surface, you know the spherical you know how the half of the spherical surface how it will be semi-spherical. How the shape of the spherical look like a yeah, it's a curve, like a curve. So if the refraction of the spherical surface where the ray of incident from the rare medium refractive index n1 to another refractive index n2. So refractive index n1 by n2 is given. Finally it's given by n2 by v equal to n2 by 1 by u is equal to n2 minus n1 by r. So now if you take for 2, now if you go for 2, what is refractive index? What is n1 and n2? What is n1 and n2?
Distance.
U and v is the distance. U is v is the distance from the internal position. U is the distance from the opposite position. U and v. Okay. U. I'm placing. I'm placing mirror spherical mirror image at the inner center place. Okay. I'm having the ball. I'm placing ball here. The image is formed at the behind that camera, behind the camera or behind that mirror image. So the distance between lens which is placed here, that distance and this distance is called u, and the distance between the lens and the image viewed that is v. Okay, you understand now?
V is what, sir?
V is
Distance between
lens that is placed here. Where I placed lens now?
Middle.
Where? Which middle?
convex between the convex mirror and V.
No, that's what I'm telling. Where I place that mirror now?
Middle.
Middle of which middle?
Under convex mirror.
No. It's between that wall and me. Where I'm standing here, I place the ball here. Where is the wall? Is there wall? That wall. There image is formed. Between wall and the ball, I place the mirror. You understood
Wall
now?
and ball between place and
mirror. So I place the wall. I am placed wall between wall and mirror. Between wall and ball, I place the mirror. Okay. Now I can now in this position where it is, what is placed? Ball. In the wall, what I will get? In the wall. What I will get? Image. We didn't understand. I have placed first. I am placed here ball. In my place, I placed ball. In the wall place, I'll be getting image. Image. Wall. Image. Okay. Between wall and me, I have placed the mirror. Okay. So what is the distance between the wall and mirror? That is u. No, that is v. Wall and mirror is v. Okay.
Wall and mirror is V or U, sir?
V. And mirror and the ball
U.
U.
Yes, sir.
Been
Okay.
now what is another one? Two is left.
Refraction through a prism.
Refraction N2 and N1. N1 is the refractive index of the before mirror. Before mirror. No, this one, that one is N1 by N2. What is the equation?
N2 by V equal to N by U equal to N2 minus N1.
N1. So what is N1 and N2? N1 and N2 are the refractive index. So N1 is the refractive index of the medium before the mirror.
N1 is the
Refractive index of the medium before the mirror.
refractive index of the
Medium before the mirror. And N2 is the refractive index of the medium behind the error. Behind the mirror. N2 is the refractive index of the medium behind the mirror.
N2 is behind the mirror.
Mirror, that's all.
Refractive index.
Refractive index. N1 is before the refractive index before the mirror, and N1 is the refractive index behind the mirror. That's all. Before the mirror, behind the mirror. Before the mirror means in front of the mirror. Behind the mirror means back of the mirror. R is the distance between from the center of the mirror to the image. Big R, capital R. R is the distance from the center of the mirror. From the
Center of the
mirror to the image.
to the image.
So now what is UVR?
U is the distance between lens and wall.
Ah.
Ball and wall.
Not wall. Wall is example. Wall. What are you going to do with wall this year? See here I am placing the ball. In between wall and me, I am placing the mirror. Wall, I told you the distance. Just an example of the distance. Wall. Now you are nowhere related to the wall. It's an image.
Okay.
Image. No, there is no wall. I am telling that distance. You can calculate the distance now. See what will be the distance between here and that wall?
U.
No. What will be approximate distance from here, from that wall to my place? What will be the distance?
1 meter.
Not 10 feet. It will be 10 feet. It will be 10 feet.
Mm.
So between the wall and me, I have placed the mirror. Okay. Now where I will get the image? I will getting the image in the wall. In the wall portion where the wall is there. There I will get a image. I have given the example.
Okay, sir.
Okay. Now distance between the mirror and distance between the lens and me. What is the distance? U. Then distance between the lens and image. What is the V? Now what is the distance? What is the R? R is from the center of the distance, center of the lens to the image. To the image, not the wall. Wall, I told you the distance. You can easily visualize. Easy to visualize. So the wall is a place where we are going to get the image. That's all. It's a simple explanation. Very simple explanation. Very simple explanation. Next, what is the next?
Refraction through a prism.
Through a prism. Okay. Now you know very well how the prism will be. Prism, how it will be? It will be like the
Triangle.
it will be like a triangle. So if it is if a light is passed to it, what it will be? Once light pass into the one surface, it will do the refraction. It will travel to through the medium of the prism, certain distance to the prism. Then it get diffracted, and then it is then it is diffracted and pass to the other region. So two types of thing is there. But what we have seen there? What we have seen there? Huh?
Colors.
No. In lens, in lens, what we see?
Image.
Yeah, we have seen lens, a lens, ball, image. How many medium we have seen?
3 medium. 2 medium.
2 medium, not 3 medium.
2 and
2 medium. Okay, and here we are going to see same thing only. Same prism we are going to take. First one is incident. Okay, then it is traveled through a certain distance of medium. Okay, and then it is after diffraction it came out. Okay, so in that means how many medium here? How many medium?
Incident. Diffraction.
3 medium.
2 medium.
2 medium, because it came
Diffraction.
incident and refraction, not diffraction, it's a refraction, incident and refraction. Then once it came back, it came to the same medium. All are, outside medium are same, inside medium is different. So outside versus inside, so it will be 2 medium. But rays will be how many rays here? 3 rays.
2 medium சொன்னீங்க sir. One incident, இன்னொரு
No, one is inside. Inside the prism is one. Inside the prism is one. Outside the prism is another one. So only 2 medium, not 3 medium. Okay. Now how many rays now it is?
3.
3 rays. How many medium?
2 medium.
How 2 medium?
One is inside,
Ah,
other is outside.
outside. So whatever I'm taking one prism and kept here, I'm passing the light. First incident light is 1, then prism. So it passing through the prism, refraction. Then it's dispersing out. So
Incident, diffraction, dispersion.
dispersion. Okay. So how many medium now it is?
3 medium.
Not 3 medium, 2 medium.
2 medium.
Because the prism is 1 medium, outside surrounding is another medium.
Okay sir.
So only 2 medium. But when the rays is there, when rays is entered, now what it is? How many rays will be now here?
3.
How many rays will be now?
3 rays.
Huh? Yeah, 3 rays. But why you blinking to so much to tell that? How the 3 rays? Because incident 1, diffraction
Diffraction
2, second one.
Dispersion 3.
Dispersion is 3. That's rays wavelength will decrease now because the rays different.
Incident.
Incident, the diffraction and the dispersion. The incident is different from dispersion now. The frequency, the velocity, the frequency will vary now. Incident,
Diffraction.
no, first is incident, no.
Incident, diffraction.
Incident,
Dispersion.
refraction, not diffraction, refraction.
Refraction.
Incident, refraction and dispersion. So the incident is not equal to, incidence is not equal to,
dispersion.
incidence is not equal to dispersion, that's correct. Because incident is different from in dispersion, because it has the wave now traveled to the diffraction medium. What the wave thing, the frequency will decrease now. Something not equal, it could be frequency should decrease or something.
Okay sir.
For all, incident is not equal to dispersion. Yeah. So what is the wave? What is the law I given? N? What is the equation I gave?
Equal to n minus 1 into a.
D is equal to n minus 1 by A. But what is DEM?
N is refractive index.
N is
A
a
area of prism.
area of the prism. What is DM?
Deviation.
Deviation. Minimum deviation.
Minimum deviation.
Minimum deviation.
Okay, sir.
Then dispersion by the prism. Then
Cut the
dispersion by the prism. So the prism is meant by to give the if you pass the white light to the glass prism, you will get the spectrum of white light, which is WIPGR. You know, right? WIPGR. Rainbow colors. Rainbow colors. WIPGR are rainbow colors. The phenomenon of splitting of light into different colors is called the dispersion. Okay.
Yes.
The pattern of colors of components of light is called spectrum of light. Okay. This you don't need. This you don't need. Okay. Then another one is I think rainbow. I think example.
Sir.
Rainbow, no. So the example of dispersion is rainbow. So rainbow in rainbow, which is the medium now? Which is the prism now?
Water.
Water droplet. Water droplet. Where the water droplet will be there?
Sunlight.
Sunlight is the incident medium. Sunlight is the incident light. Medium is
Atmosphere.
no, here okay, not that much. Not 25% answer is correct. 100% answer is clouds.
Clouds.
Clouds. Water droplet is the actual thing, but where it is present here? It is present in the
Cloud.
clouds. So clouds is the thing.
Already aligned.
Okay, what is the next topic?
Optical instrument.
Optical instrument. What is the first thing?
In microscopic linear magnification M for an image formed at the point D is given by M equal to 1
1 plus D plus by F. What F is the focal length? M is the
Linear magnification.
linear magnification. D is the
Deviation or dispersion, sir?
dispersion. It's a dispersion.
Dispersion.
Okay. So what is purpose of a microscope? You know very well. You can see that
Microorganism.
microorganism. So for example,
Coronavirus.
a virus. Okay, coronavirus you can take. You're having food, right? Food. You are every day having food. Same food you keep it outside. Okay. Just purchase it the food. Keep it outside. Leave it as such for 1 week. Then you take the food and eat. What will happen if you take after 1 week? Huh?
It will
After 1 week.
poison.
Okay. Why it is poison? Due to
Microorganism.
due to formation of microorganism. That that's from the ordinary food. If you take after 1 week, you can't see that microorganism in the naked eye. But the same, take a splinch of it, put it in the microscope, and see it. You can see that in the microscopes.
The telescopes.
No, telescope is different.
And
Microscopes.
Then the topic is telescope.
Next, okay. No, what is the D I told?
Dispersion.
Equation is M is equal to 1 plus D by F. Okay. D is the distance from the image to the lens. D is the image to the lens. D is the distance from the image
To the lens.
to the lens. Yeah, next is telescope. You know very well. You can't see the distance object like Mars extraterrestrial asteroid, Mars asteroid in your naked eye. Or we don't want to go to that level of outer solar planet. Just Mars, Jupiter, what is present in our solar system. Mars, Jupiter and asteroids. You know, right? Some of the asteroids are rotating us. So this recently also last May, I think. Last May and last 2020 May, it has passed. When the 2020 May, it is the distance between that asteroid which is passed toward Earth is very less, nearly 1 lakh kilometer. No, not I think. Nearly 1 lakh kilometer. Now that same asteroid, it has passed to us from Earth inside. What is next to Earth? Next to Earth? No, Mars is after this side, towards Sun. Earth, Venus, Mercury. Then you will get Sun. Okay? So it has passed all the planet and it has taken the U-turn. How will you take the traffic? U-turn. Like that, it has taken the Sun. After rotating the Sun, it has taken the circular path of U-turn. Then again it is travelled and it has passed the Sun, Mercury, Venus, then Earth. So this when it passed, it is last 2020. The distance is very less, around 1 lakh kilometer. When it passed towards last month, few weeks back, May first week it has passed. So this how they calculated 1 lakh kilometers. This one is 5 lakh kilometers. 5 lakh kilometers is which distance? Long distance. So it can't be viewed that much easily, but here it is viewed is properly. So if it is so, what is the distance? What is the distance between Earth and Moon? Earth and Moon distance 5 lakhs, approximately 5 lakhs. So this asteroid travelled almost on the same distance between the Earth and Moon. So we can able to see the Moon, right? But we can't able to see the asteroid. Why? Because size is less. If size is less, we can't see it. But in the telescope, we can view the size. In the telescope, you can we can view the size, and they calculated almost the distance is same. It travelled in the distance of the Earth to Moon to the Earth of asteroid is same, like the same distance is it has moved. So this is one of the big application of the telescopes. They viewed it clearly how this when it traveled 2020. So 2020, mid 2020, same May it has traveled. May to May means how many years?
1 year.
No, 2020 May to 2022 May.
2 years.
2 years. So 2 years it took to travel. That means it took 1 year to travel from Earth to travel Sun. From the Sun it has to travel to Earth. It has taken again 1 year. So 2 years exactly it took for it has crossed. So now where it will reach now? Huh? Where it will reach? It will reach to Mars belt. Mars belt. Where is Mars belt is located? Between Mars and Jupiter. Between Mars and Jupiter, Mars belt is located. There it is. All the asteroids are placed over in the Mars belt. So it will reach towards the path. It is not only astronaut. Annually we will be getting many asteroids, and there is no 1 or 2 asteroids in the Mars belt. There are millions of asteroids. 1 million is equal to how many things? 1 million is equal to how many lakhs? 10. 1 million is equal to 10 lakhs. Millions means 10 lakhs, 20 lakhs, 30 lakhs or asteroid. It's a big rock of almost 10 kilometer size, 10 into 10. Length will be 10 kilometer, breadth will be 10 kilometer. So this much of size the rocks are. Almost like a mountain. Always. You have seen mountain?
Yes, sir.
Where? Not here. You can't see it. This is full of city. If you cross a...
Vellore, sir.
Huh?
I saw it Vellore.
No, you can go to Tambram. Tambram, Vandalur, Urapakam. If you say Vandalur Zoo, did you ever went to Vandalur Zoo?
Yes, sir.
Yeah, went, no? That's full of mountain only, no? It's almost one rock will be almost like a one mountain size. So there are millions of rocks in asteroid belt that will travel like this. Okay, so that we can view clearly. So that is application of telescope. So what is the length given?
M equal to FO by FE.
M is FO by F
E.
E. So what is FO?
Focal length of the object.
Uh,
FE is focal length of the eyepiece.
Eyepiece. Yeah, correct. So that's all. That's all. This chapter over. So next is wave. Okay. When we started? Something 9:40. So 10:30.